Hi, this is John. This video is on basic techniques of using epoxy. Epoxy is the most important construction material in high-power rockets and mid-power rockets, and it's definitely worth spending some time to look at the techniques, types, and uses of epoxy.
First, let's talk about the types of epoxy. There are two main types for different purposes: structural epoxies and laminating epoxies. Most people's first epoxy is hobby shop epoxy. JB Weld has special purpose uses, and then it's on to the epoxy systems. Laminating epoxies are more special purpose, but still have important functions for building rockets.
So what's the real difference? Laminating epoxy is thin, and it can saturate fiberglass or other reinforcement fabrics, which allow you to create a surface on an existing part or make a whole part. These are called layup techniques of fiberglass. We're not going to cover laminating epoxies in too much detail in this video, but you should see my video on glassing a tube for an example of how I made this tube. So we bond our parts together with structural epoxy. So I laminated fiberglass onto the surface of a phenolic tube with laminating epoxy, but then when I went to bond the coupler in, I used structural epoxy. Structural epoxy is what we use for the majority of bonds: couplers and bulkheads into tubes, fins, external fillets. Pretty much all general bonding techniques are done with structural epoxy. Epoxy always comes in two parts: the resin and the hardener. Whether it's small tubes of hardware store epoxy or larger volumes of an epoxy system, they always come with the two parts separated. The reason for this is when the parts are put together and mixed, a chemical reaction starts which will eventually form a solid mass bonding the parts together. So one very important characteristic of epoxies is the working time or pot life. For example, 5-minute epoxy refers to the fact that you have about 5 minutes to mix it and apply it to the part before it cures. Longer working times can be achieved by using different epoxy formulations. With an epoxy system, typically you'll have one resin and multiple hardeners that give you different times. Usually there'll be a fast hardener and a slow hardener, or even multiple different speeds. If you have a part that's going to take you a long time to put together, particularly with laminating epoxy where you're working with a large piece and applying fiberglass and getting everything right, you want a little bit more time. With bonding, you generally want as fast a hardener as you can get, because you're going to have the pieces in place, tacked together with CA or held mechanically, and then you're going to apply the epoxy and you want it to pretty much cure as quickly as possible so you can move on to the next step. But in general, you should understand the idea of pot life and the different working time you have. Speaking of that, the epoxy goes through 3 stages. You have your working time, or your pot life. Then you have your initial cure, which is when the epoxy becomes firm and can be handled. And then finally you have your full cure. These times are listed with the epoxy, at least approximately. I say approximately because the times are very dependent on temperature, and they're also dependent on the volume of epoxy that you mix. The chemical reaction for epoxy is exothermic, which means it produces heat. So if the ambient temperature is hot, or you mix a large volume, the heat produced by the reaction will actually cause the reaction to speed up. So if you're working at above normal temperatures, or you're mixing large batches, you'll actually have less pot life than what is listed with the epoxy. Okay, let's talk about an epoxy mixing area. Mixing epoxy is messy, so what I like to do is put my epoxies on a disposable foil tray so the drips don't damage the work surface. So what I have arranged here, some tools and supplies, cleaning, my epoxies, and the all-important gloves. Some useful supplies: cheap salsa cups, for mixing structural epoxy, cheap medicine cups for mixing epoxy by volume. A little more expensive, easier to use, are painter's measuring cups, also for measuring by volume. And of course, for mixing, tongue depressors, popsicle sticks, and Starbucks coffee stirrers are really useful. Now you'll notice that I'm using Epoxy. What I've done is I've dispensed the structural adhesive into squeeze bottles, which makes it much easier than trying to dispense it out of the metal cans. Similarly, for the laminating epoxy, I've used West System pumps, which again makes it easier to dispense when measuring by volume.
Let's talk about mixing. The resin and the hardener are not always mixed in the same amount. Sometimes the ratio is 1:1, and sometimes the ratio is 3 resin, 1 hardener, or even 5 resin, 1 hardener. There's always more resin than hardener if there's an unequal ratio. An additional complication is that sometimes the ratio is by volume and sometimes it's by weight. The manufacturer will give you the mix ratio and you must use that method. Since the two parts are not necessarily the same specific gravity, if they give you a ratio by weight, mixing by volume will give you the wrong amounts, and vice versa. So we'll look at 3 mixing techniques. For small volumes of epoxy that's mixed equally by volume, we'll use the equal blobs method. For larger amounts of epoxy that are also mixed by volume, we'll use measuring cups. And finally, for epoxy that's mixed by weight, we'll use a scale.
Now before we mix any epoxy, let's talk about safety. Modern epoxies are not terribly toxic. However, they do have chemicals in the hardener that will cause sensitization. What this means is that repeated exposure can cause you to develop allergic reactions, which will basically make it miserable or impossible to use epoxy in the future. So, some simple precautions. Always use gloves when mixing any volume of epoxy, and try to work in a ventilated area so you don't have fumes build up. Now, the equal blobs mixing technique is useful when you have a small amount of epoxy where you can eyeball it. Hobby Shop Epoxy even recommends this as the mixing technique to use. In this case, I'm using JB Weld and mixing up a small amount that might be used to attach a motor retainer or other small bond. Luckily, with these kinds of epoxies, the ratio isn't incredibly precise. We just do our best to get the same amount by eyeball. It's also convenient to have a 3M pad that we can mix on, and when we're done, we just tear off the top sheet and throw it away. So we have our equal blobs, and we just mix them together until the color is uniform. So this is our simplest technique and the one that most people will start with.
Laminating epoxy is usually mixed by volumes. It's thinner, so it flows more like a liquid, and you also tend to be mixing larger amounts. Epoxy publishes the ratios by weight and by volume for their laminating epoxy. This is a good example where you have to use the right method. Note that by weight, it's almost 4:1 ratio, whereas by volume it's 3:1. Medicine cups are very cheap and are easy to use for mixing, but you have to do a little bit of calculation. For a 3:1 ratio, you have to have 3 times as much resin as hardener, which is a total of 4 parts. For example, to mix half this measuring cup of 40 milliliters, that makes 30 milliliters of resin, 10 milliliters of hardener. To fill up this measuring cup for 80 milliliters, we just double those amounts. So it's relatively easy to calculate the volumes. Just remember that the ratios tell you the proportion of the 2 parts, but then you add those 2 numbers together to get the total. So if you start with an evenly divisible number of the sum of the two ratios, it's easier to do the calculation. An easier to use alternative to measuring cups are painter's cups. These come with the ratios predetermined, so there's no calculation. You just use the built-in markings. First thing you do is find the ratio that you're trying to mix. Then you choose the number in the second column that corresponds to the total amount you want to end up with. Pour resin up till the first column of that number. And then finally pour hardener up to the second column, same number. And if you want a larger amount, you just use a different number. And that's all there's to it. However we measure, we need to mix thoroughly. If the two parts are different colors, we need to mix them until they reach a consistent, smooth color. But in any case, we want it mixed for at least 1 minute. Mixing by weight is actually easier and more precise, and is the best way to mix structural epoxy. First, we take our scale, I like to use grams, place our mixing cup on it, and tare it. Since this ratio is 1:1, by weight, doesn't really matter which one we put in first. We'll do resin first. We choose a convenient amount. Notice how the scale responds really quickly. I only need a little bit for this job, so I'm going to do 1.5 grams. Then the same weight of hardener. Note that the hardener is a little more viscous, and again they have different specific gravities, so that's why weight measurement is the most accurate. We're going to double our first 1.5 and weigh a total of 3 grams. And there we have our equal amounts by weight. Once again, it's extremely important to mix thoroughly. This structural epoxy has different colors, so we can easily see when it goes from brown and white to a smooth straw color. But again, we want to mix it thoroughly for at least a minute. Okay, now that we've talked about types of epoxy, measuring, and mixing, let's talk about application. One very important thing to remember about epoxy is that it has great structural strength capabilities, good gap filling properties, but it requires a roughness of the surface to bond to. It won't bond well to smooth, slick surfaces. So we have to make sure that any surface we're bonding has some coarseness for the epoxy molecules to lock into.
Porous materials like wood or cardboard are fine because they naturally have a rough surface. Smoother surfaces like phenolic or fiberglass need to be sanded. Let's take a look at a typical cardboard rocket and its components. Here are some very typical parts for a high-power rocket. We have tubes made of cardboard or heavy paper and centering rings made out of plywood. Now you notice that the inside of the tube is still rough, and epoxy will bond to that very nicely. But the outside of the tube has a glassine surface, and we'll have to remove that shiny part so that the epoxy can bond into the cardboard. So, as is typical, we want to mount this centering ring a ½ inch in from the end of the tube. But as you can see, the centering ring isn't a really tight fit, and we can line it up with the mark that I've made, but there's nothing to guarantee that it will be perpendicular, and in particular it'll move around. So we want to prepare the surface a little bit better before we begin the bonding. Of course, the very first thing we need to do is scuff up the glassine coating in the area that we're going to bond to. You can do this with the little sandpaper. Here I've got 150 grit, just enough to sand into the glassine and give us a rough surface to epoxy to. As you can see now, we have our surface. The second thing we want to do is make a line all the way around so that we make sure the center ring's lined up. An easy way to do that is to get a piece of paper, wrap it tightly around, and then make sure that the edges meet. This will mean that there's a straight edge all the way around the circumference, and we can just run our pen next to the edge of the paper and mark all the way around the tube. So now we have a guideline all around the tube, and we have the glassine surface scuffed up, so we're ready to position the ring. Make sure the line just shows all the way around. You can also double check it with the ruler if it's a critical one. Checking at 3 different points around the circumference. Now, we have this correctly positioned, but it's not extremely secure. So we want to make sure it doesn't move while we're applying the epoxy. So what I like to do is put a few drops of CA on maybe 3 different places. This will make sure that the parts stay in alignment during the epoxy application and while the epoxy cures. Okay, we've mixed up our structural epoxy, and we're ready to apply a fillet to bond this centering ring to the motor mount tube. Go ahead and apply the epoxy generously all around the perimeter of where the fillet will be. Then what I like to do is spread it around with a finger. This does 2 things. One is it smooths the fillet, makes it prettier. Not that that really matters. But the other thing is it makes sure the epoxy is pushed all the way into the corner so we get the maximum surface for the bond. You can just drag your finger around and you can see it's pulling an epoxy dam in front. That makes sure that we have a consistent amount all the way around, and it's forced all the way into the corner. And then we set our part aside to fully cure. Another common body tube material is phenolic. This is essentially also paper, but it's wound under pressure with adhesive, and so it's a much harder surface. Because of the way it's produced, it also has a smooth surface to which epoxy won't stick without sanding. So if you use phenolic, make sure you sand before you apply the epoxy. And of course, fiberglass is also non-porous. So I wipe down the surface beforehand with acetone to remove any residue from the manufacturing process. Then I sanded lightly but consistently with 220 sandpaper. And now I will wipe off the dust with alcohol. One of the nice things about working with phenolic or fiberglass is it doesn't really have an issue with liquids, so you can use alcohol to clean the surfaces as much as you want. Once we wipe off the surface, it looks like we didn't sand at all, but if we look very closely, there's some milkiness of the surface that shows that we did rough it up. So another common bond that will exist in every rocket is a fin fillet. This is pretty much the same as what we did on the centering ring, except this is going to be external. Now, this doesn't have to be perfect. It's not a cosmetic fillet. We'll do that later, but we might as well get it as nice looking as possible to make the finishing step easier. In particular, we don't want to have any leftover blobs because it's very hard to sand structural epoxy, and you don't particularly want to breathe the dust. Again, we lay in our epoxy into the fillet, making sure we have plenty, and then we smooth it out. Now, different people have different favorite techniques for smoothing it out. There's the plain old finger technique. You can try using a scraper. Some scrapers come with corners, so we can run this along the angle here. Get a smooth fillet. Another thing we can do is use a plastic spoon. The nice thing about the plastic spoon is the excess epoxy tends to go up into the bowl instead of smearing out along the two surfaces. So it gives us a little less cleanup work to do afterwards. Whatever technique you use to smooth out the fillet doesn't really matter, but just make sure, again, that your epoxy is even, thoroughly pushed into the gap, and that you get rid of as much of the excess epoxy that you don't want on there as possible. Here's a close-up of our fillet after application. Note that it's already pretty smooth, but the epoxy is actually somewhat self-leveling, so it'll even get smoother before the epoxy cures fully. Some people also like to run longitudinal tape strips before they put in the fillet to avoid having excess drips. I find that's not particularly necessary, but you may try it. But whatever you do, get rid of the tape before the epoxy cures, because you don't want it to lock the tape into place. And finally, a few words about cured epoxy. Once the epoxy cures, you have your strong bond that you were originally trying for. But it's important to understand that epoxy won't stick to previously cured epoxy for two reasons. One is the epoxy forms a hard, slick skin, so you don't have the mechanical bond. And the other thing is the epoxy chemical reaction will produce a surface coating called an amine blush. If you do need to epoxy to an already epoxied part, make sure to remove the amine blush with acetone and then sand the surface just as you would any other part in preparation.